Amazing.
Vedantu. Learn live online. To attend a free live class, download the app now.
Hello everyone. Good afternoon. Hi Pratiksha, you are there on time. Good. Who all are there? Ullas? No one else? Hi Shrestha. So make the session active. I don't want to feel it as a very dull session. Make it active. You have to make me active, then only we all can make this session super active, right? Hi Rishan. Hi Harsh, Ritesh, Deepali, Anchita, Harsh, Blitz, Devanand, Abhyuda. So tell me, how are you all doing in this very fine afternoon? Doing good, great and awesome. Tell me, how is this afternoon taking care of you? Hi Nantini, so many highs. I'm so happy with that. I think my day, no, I went to gym, okay? So my day started with the gym. After that I came here for the class. So now I'm having a good chat with you guys, right? Watching cricket. So switch off the cricket channel, whatever you're watching, and now listen to me, okay? So I think this phase is at least good so that you can watch it for 40 minutes, right? And we can do lot many problems also. So doing good. Good afternoon. Hi. So fitness freak. Drink Red Bull. Why? I look so dull or what? Okay, so let's not waste our time. So I'm not asking you how your preparations are going on for the exams, because I know that my students are doing super good and super great. Yes, I hope so, and keep my beliefs as such. Now, those who don't know me, myself Ameer Basit, Master Teacher of JEE Physics at Vedantu. You can call me Ameer for anything and everything, but only for physics, right? Okay. So, as you all know, we are here for the CBSE sprint to make ourselves prepared for the upcoming CBSE board exams, right? Okay, thank you so much, Aditya. So, what we'll be doing for that, we'll be covering up all the previous year questions, chapter-wise chapter, and we'll also be doing a quick revision of the chapter. So, as you have already know, what is there? We have almost completed these many topics, right? So till 29th January we have completed these many topics. Don't worry that you have missed. It is still available in the YouTube. After this session you can watch it again, and I think we have did enough number of awesome questions there. Okay, so go and watch it. Thank you so much, Ankit. Okay, good look. Thank you so much. So yeah, I just made a haircut. So is that visible? And I shaved also. Is it looking good or what? No? Yes? Yes, Pratiksha. What about others? No reply? Okay, good. Okay, so as the chapter current electricity is more important, we are going with the second session with the same chapter, right? So guys, we have done enough number of theory classes and I have explained about all the Kirchhoff law and all those things in the last class. So shall we start with the session? So this was for this particular week, and in the next week we have all these classes at 1 o'clock. So be there at the right time. I'm from Kerala. You look always good. Okay, so Pratiksha deleted. So you have failed even SRK. Oh my god, that's so much. So let's talk less and learn more. So shall we start with the session? Guys, tell me, shall we start with the session? Yes or no? Okay, so here we go with the first question, right? So we are going to continue from where we have stopped in the last class. Okay, so let's concentrate. So let's keep our chat less and learn more. So the question goes like this. Calculate the value of the resistance R. Where is the resistance R? This one. Okay. In the circuit shown in the figure, so that the current in the circuit is 0.2 ampere. So the current in the circuit, what you can see over here, it is 0.2 ampere. What would be the potential difference between the points B and E? So we have to find out the potential difference between this point. So if you want to find out the potential difference between these points and the value for this resistance R, what do you have to do? You have to solve out the circuit, right? So first thing what you want to find is you have to find out this particular R, right? So how to find out that particular resistance? So in order to find out that particular resistance R, we can make this bigger circuit, what you can see over here, simpler, right? So can you tell me how this 5 and 10 are connected? Who will tell me? Before starting with the Kirchhoff law, we have to make the circuit simple. right? Tell me how this 5 and 10 are connected. This is connected in series, and this 5 and 10 together in series is connected with this 10 ohm. How? To this 10 ohm. Very good, Pratiksha, Ritik, Rajiv. Okay, to parallel, and this is also connected with this 30 in parallel, right? So we are going to make this particular series circuits and parallel circuit into a simplified version. So this 10 and 5 will make series 15. So 15, 10 and 30 are connected in parallel. So equivalent value for resistance will be equal to, how much we can write? How much? So 1 by R equivalent is equal to, how much it is? 1 by 15 plus 1 by 10 plus 1 by 30, right? So let's make it as a common. So multiply it with 2, 2. So 3, 3, so that we'll have a common denominator. So add it up. This is equal to 6 divided by 30. So R equivalent will be 30 by 6, which is 5 ohm. So this entire series of resistor can be replaced by 5 ohm. What you can see in the next figure over here, right? Can you see this? So the entire thing is being replaced with 5. Now this R has to be found out, but already one thing is given. What is given? The value for the current was given as how much? The value for the current is given as 0.2. So in order to find this out, we can use Kirchhoff's second rule, right? Okay, so what we can do? So you know that a current of this here itself I am writing. Okay, so here itself I am writing 0.2. So starting from this particular point, which let me mark it with red, starting from this particular point about Kirchhoff's second loop rule, what is there? The sum of the potential difference or the potential drop in a loop will always be 0. So I have explained you this in the previous session. So those who don't know the Kirchhoff second law, go to that previous and watch it. Okay, so it will be very much helpful. Starting from this, so I'm moving, and what is happening? An 8 volt is added up because we are ending up in the positive potential of the cell. So what I can write? So plus 8 it is. Okay, so plus 8. Now I'm traveling in this particular thing. Okay, I'm traveling in the clockwise direction, in the same direction of the current. So across this, a current will be dropped. So how much is the current dropped across? Sorry, voltage dropped across this? V is equal to I into R. I is equal to 0.2 and R is equal to 5. So with negative sign, because we are traveling in the same direction of the current, so that is 0.2 into 5, right? Okay, then it goes. Some potential is being dropped across this R. So I'm writing it is minus 0.2 into R. Then we have to subtract this value because we are ending up in the negative of the cell. So it is how much? Minus 3. Then again we are traveling in the same direction of the current. Some potential is dropped across this resistor. How much it is? Minus I into R is 0.2 is equal to 0 because we have reached at the same point. Okay, now how can we what will happen? So what I am doing is 8 minus 3 is equal to 5, right? So 5 is equal to this entire minus I am taking it to the right hand side where 0.2 is a common. So 0.2 into 5 minus 15, right? So everything is with negative over here only. So I'm taking the negative also. Oh, sorry, it will become positive. Then it is plus R, right? So this is what happens. Now 5 divided by 0.2, how much it will be? It is 50 by 2, 25. So 25 minus 15 plus 5 is 20. So R value will be how much? What is the value for R? 5 ohm. Understood everyone? Yes, all good, happy? So this is how we do the problem, right? Understood or what? Yes, very good. Then there was a small question. The potential difference between the points B and E. How will you find out the potential difference across the points B and E? How will you find it out? How will you find out? Who can tell me the potential difference between the points B and E, which means this B and E? Who will tell me? Nobody is there to give me the answer or what? Don't have to do anything. Yes, very good. The potential difference across this point B and E will be equal to what? Look, this is point B, right? And this is point E. So across this point, the potential drop will be equal to. sorry, the potential difference will be equal to the potential dropped at this resistor, right? Yes or no? So what is the value for potential dropped across this resistor? How will you find out? That is equal to I into R. Understood that particular concept, what I said? The potential difference between these 2 points will be equal to what? Whatever is the potential dropped across this resistor, because in between the only thing that is there to make a potential difference is this resistor, and the potential difference will be equal to the potential dropped across this resistor, and how much it is? I into R. I is how much? 0.2 and R is 5. So 0.2 into 5 will be equal to how much? 0.2 into 5. I know that you are super dashing in mathematics than me, right? Yes, Prachi, okay, very good. So I couldn't read that, I'm sorry for that. Those who said the answer, it's good. So it is 1 volt across the points B and E. All good, right? Happy everyone? So you got a simple question just like that. So next question, all good, Roshan, Srivanshu, Ritik. Great, Shivansh, okay. So I'm so happy with that because all are so active at this point of time of afternoon where everyone else will be sleeping, okay. So next question. Mark and clear, good. Shrestha, okay, one, good. Next question. So the question goes like this: two heating elements of resistance R1, okay, R2, when operated at a constant supply of voltage V, consume power P1 and P2. Which means if I am connecting a resistance R1, look. Okay, so here we have the resistance R1. Okay, I am connecting across a potential V. The power is equal to P1. How will you write power in terms of voltage and resistor? I hope everyone knows, right? Power is equal to V square divided by R1, or I can write R1 is equal to V square by P1. Yes? Yes or no? Okay, now similarly for the second case, instead of R1, if I am replacing this R2, so R2 will be equal to the same voltage divided by P2. I hope nobody is having a doubt on this, right? Simple as that. Yes, good. Okay, so the first question goes like this: deduce the expression for the power, okay, the total power whenever it is combined in a series fashion. So these two resistors are combined in a series fashion across the same voltage. How will it be? This is R1, right? So this is R2 and you have the same potential V across it, right? So you have to deduce a formula for what? Deduce a formula for the power. Yes, Pratiksha, it's good. Yes, Deepika also said the correct. Okay, for parallel it is P1 plus P2. For series, let's see. So how will you write? The equivalent resistor R is equal to R1 plus R2, right? Okay, R1 you have from here. What is it? That is equal to V square by P1 plus R2 is equal to V square by P2. Yes or no? Okay, so this total resistor R can be replaced as what? The total resistor or the net resistor can be written as whatever is the voltage now we are giving across these two resistors. What it is? The total voltage V itself divided by the current power or the total power in this particular case of connecting the two resistors in series. So that I am writing it as P equivalent. Okay. So what I can do, V square I will be cancelling from everywhere. So what I will get, 1 by P equivalent is equal to 1 by P1 plus 1 by P2. So this is how the relationship between the powers when the resistors are connected in series. All good everyone? Prachi, Pratiksha, yes, everyone happy? Okay, repeating it is not so important because everything is being recorded. Okay, so if you understand what I have done is, in this particular case, the net resistance I have written it as R1 plus R2 and I have substituted for R1 and R2 from the previous equation whatever we have written. That's all we have done and cancelled off the things. So V square cancel because this is common, right? So it is 1 by P equivalent is equal to 1 by P1 plus 1 by P2. That's all I have done. Yes, understood, right? Now let us go for what? The second case. When they are connected in parallel. When they are connected in parallel, how will you write the equation for resistance? 1 by R is equal to 1 by R1 plus 1 by R2. Right? Yes or no? Yes? Okay. R1 can be written as what? R1 can be written as V square by P1, so it goes up, plus this will be equal to V square by P2, P2 goes up, right? So the equivalent value for resistance can be written as the net value of potential across the parallel will be the same, right? V square divided by equivalent value for power, power goes up, so P equivalent, yes or no? So V, if you cancel from everywhere, P will be equal to P1 plus P2, in which case? In the case of parallel. Yes, simple as that. Yes, I hope all my sweet bajjas understood this, right? All good, happy, awesome, great. That's good and very awesome. So did you know Hindi or do you know Hindi? What I can say, thoda thoda mujhe janta hu Hindi, but my grammar is so bad, right? So because I don't know when I use may, where to put whom, when I use up, where to put hey, who, so everything is confused. So I can use words. I know what do you mean by gargosh, what do you mean by titli. So okay, yes, I'm from Kerala. So that will be the best answer if someone asks you where you're from, like whether you know Hindi or not, right? Okay, so good. So next question. So entirely based on Kirchhoff loop rule, right? Okay, state Kirchhoff rules. Okay, Kirchhoff rule we have stated already in the first session, right? Okay, so I'll explain those whoever is new to this particular session, okay, in a glimpse. Okay, I'm not going to explain in a bigger fashion, in a small fashion. Okay, so Kirchhoff first rule says what? Whatever is the current coming into the junction will be the same amount going, right? You know that it cannot get accumulated anywhere. So if 5 is coming to the junction, 5 will be coming out. So what I can say, I'll give you a small example on that. So look, so this is I1, this is I2, right? So if I1 and I2 is coming to the junction, current cannot get accumulated at the junction. So whatever is coming, it has to go out. So the going count is I3. So what can you write? I3 will be equal to I1 plus I2. Simple as that. Okay, so don't have to learn much, don't have to know less also. So that is about the Kirchhoff first law. And what about the second one? What is said in the second one, Kirchhoff second one? It says the algebraic sum of the potential drop or gain across all the elements in a closed loop of the circuit will always be equal to 0. Okay, so those who haven't understood that, we'll do it once again and see what is it. I know that for most of you guys the problem will be with the Kirchhoff second rule, right? Okay, so think that you are having a cell E1, this is resistor R1, you have a resistor, sorry, cell E2, resistor R2, and it is connected, right? Okay, so what is it said is across, or sorry, in a closed loop the total potential drop or gain is equal to 0. So let's see, I'm marking the potential here as A. Okay, so VA, I'm traveling in a clockwise direction, right? So when I'm traveling in the clockwise direction, look, I hope everyone can see, right? Okay, I'm traveling. So this will add up the potential because it is in the same direction, right? Or we can say that if we end up in the positive of the cell, this is the simplest way you can remember. If we end up in the positive of the cell, EMF will always be added up. So this can be written as what? E1. Right? So when the current is flowing and as we are moving in the same direction, some amount of potential is dropped across this resistor. So the potential has to be subtracted. Or you can also say in a better manner, if you are traveling in the same direction of the current, think that the current I is moving in this, what happens is there is a potential drop across the resistor. As it is drop, we have to subtract the value. So how much it will be equal to? I into R1. We are traveling, finding another cell, and this cell is subtracting the potential because we are ending up in the negative of the cell. So it is with the negative E2, right? Again we are traveling in the same direction of the current, so some potential is dropped, so it is minus IR2, okay, will be equal to how much? We are reaching at the same point. So all if you do all these things, okay, we are reaching at the same point, which means it will be equal to potential of A itself. So what I can do? I can cancel these two. So what will become over here? 0. That is what is said in Kirchhoff loop rule. That's all. Understood? All good? Happy? Everyone? Okay, so if you have understood, let's go with this particular question, right? Okay, so here we can see a circuit 4, 1 and 2. Okay, and they're asking you to find out this current I1, I2 and I3. Let's see how to do it. First, in any of the loop rule equation, we have to use the first one. Okay, thank you so much, Anjali. Okay, so we have to use it two rules. First rule let us apply, which is the junction rule. Okay, you can see that this is the greatest voltage. This is pushing off some current I3. So I3 is coming and reaching at this point. It is branched into two, I2 and I1. So you can say that according to junction rule, I3 is equal to I1 plus I2. Yes or no? Yes. So that's what I'm going to write it over here. Okay. So I'm going to write I3 is equal to I1 plus I2. Let it be there. Now you have to use which rule? You have to use Kirchhoff loop rule for finding out I1, I2 and I3, right? Okay, so let's take this particular loop first. Okay, I'm going to take this loop starting from this particular point. Okay, so I'm traveling in the same direction of current I1 initially. So what happens? We are reaching at the negative of the cell when you are traveling. So it is -2, right? So I'm writing it here. It is -2, right? Then some current will be dropped across this resistor as we are traveling in the same direction. So that can be written as 4 into I1 with a negative sign. So minus of 4I1. So we are traveling. Then you are taking this loop. Okay, so in this particular loop we are traveling in the opposite direction of the current of what? I2. I2 is in this, but we are traveling in the opposite direction. So potential has to be added up, right? So that is plus 3I2, right? And we are ending up in the positive of the cell when you're traveling in the clockwise direction. So it is plus 1 is equal to 0. Yes? Okay. So what can I write? Minus 4I1 plus 3I2. Minus 2 plus 1 is -1. So when it goes to the right, it will become 1. First equation, right? When we have traveled in the first loop. Now let us take the second loop. Let us travel in the same clockwise direction. Are you ready? So let us start from here. Okay, so we are traveling in the same direction of the current, reaching at the negative of the cell. So first is -1, right? Traveling in the same direction of the current. It is negative 3 into I2, negative of 3I2. I into R. I hope you understood, right? So we need three equations. First equation we have already made over here, right? Okay, so then we are traveling. Current is in this direction itself. We are also traveling in the same direction, so it is negative. So look, I3 is in this direction. We are also traveling the same direction, so it is negative of 2 into I3, right? But I3 I'm using it for what? I3 I'm using it as I1 plus I2, right? So yes, I2, then we are traveling, reaching at this cell and ending up with the positive of the cell, that is plus 4, 0. Yes, so we have made the equation second also. So let us make it 3I2 negative minus 2I1. So let it write minus 2I1, right? So minus 3I2 minus 2I2 minus 5I2, right? Minus 1 plus 4 will give you plus 3. When it goes to the right, minus 3, right? Okay, now the only thing left is what? Simplification. So I hope everyone can do. Let me do the first part and you guys can continue and get all the answers. So it is minus 4I1, it is minus 2I1. So I'm multiplying this particular equation with 2. Okay, I'm writing it as the same equation. So multiplying this entire equation by 2, this will become minus 4, this will become 10, and this will become minus 6, right? I hope nobody is having a problem with it. Now subtract the equation 1 from 2. Let this be 1, let this be 2. 1 minus 2 minus 4I1 minus 4, this will become 0. So 3I2, this will become how much? 3I2 minus will become 13. So that is plus 13I2 will be equal to, this is how much? 1 minus 6 is 7. So which will give I2 is equal to So you got the value for I2, right? Okay, already so many got it. What about others? So you got I2 as 7 by 13. Now putting this I2 in this particular equation, you will get for I1. So once these two are done, put for I1 and I2, you'll be getting I3. Okay, Upkar. Okay, awesome explanation. Thank you so much. Blitz. Everyone happy with this explanation? Everyone understood this particular question, how to approach it, how to start with the question, how to do this? So you got actually 5 marks for this particular question. Thank you so much. Okay, Daksh. So shall we move forward with the next question? Awesome. Okay, then it's great. So let's not waste our time because the exams are coming. We have much to learn, right? Okay. So those who want to check whether the answers are correct or not, we have looked only for I2. I1 value is 2 by 3. Okay, and I3 value will be 9 by 13. You just have to simplify. Let's not waste our time on simplification, right? Let's move forward. Another question. Okay, it's actually a 5-mark question. Okay, very good Anjali, Pratiksha, Roshan. Okay, so the question goes like this: state Kirchhoff rules. Okay, we have already done that, so we are not doing the first part because we are going on doing with the same explanation again and again. Okay, so when you write the exam, this is a 5-mark question, you have to attend the first part also. We will concentrate actually on the second part of the question, which says two cells of EMF E1 and E2 and internal resistance R1 and R2 are connected in parallel, right? Okay, so derive the expression for the EMF and internal resistance of a single equivalent cell which can be replaced. So what the question is, you have two cells, okay, with internal resistance connected across in parallel connection, right? So they are asking with what value of a cell these two can be replaced by a single cell, which they are asking is the net value of the EMF and net value of the equivalent resistance. Hi Pratik. Okay, so don't spam, it's not a good thing, right? Okay, so let's start with the question, right? Okay, all good. So what we are doing over here is we are connecting a cell of EMF E1, its internal resistance is R1, okay, across another cell, okay, across another cell of E2 and internal resistance of R2, and let's make this as a connection, right? Okay, all good, happy till here. Okay, now they are asking with what value of this potential has to be replaced by a single cell, which means I have to replace these two cells with a single value of potential, which means what will be the common potential is what they are asking, which is this value if they are connected in this particular fashion is a question. I hope everyone understood the question, right? They are asking you to find out this common potential, that's all. Which means if you can replace these two cells by a single cell, its potential should be the common potential. You can explain that manner also. Okay, so how will you find this out? Look, think that a current of I1 is going in this. Okay, so it will be going, think that the current is I2 over here. You know that what? You know what? Current I1 is equal to I2 because it is a single loop, right? So everything is connected in that loop, so the current will be the same. So what I'm going to write is I1 is equal to I2, right? Nobody is having a problem. So what is I1 actually? This is V, right? So the potential here is V, here it is E. So I1 is a current passing through the resistor R1 where there is a potential difference across R1 as how much? E minus V. Yes or no? Or E1 minus V. So current I1 is a potential difference, the I1 is a current passing through R1. How will you find out R1? R1 is equal to, the current passing through that is equal to net potential divided by net resistance. Yes or no? Okay. So what is the net potential across R1? That is E1 minus V divided by resistance. I is equal to V by R. Same equation I have written, right? Equal to, what is I2? Okay, what happened? So many are going. Google bye. What happened? If you can stay back. Okay, so I1 is this, and what is I2? I2 is a current passing through this resistor from here to here. So if the current is passing from this particular point to here, which potential will be greater, V or E2? Guys, tell me, Blitz, Roshan, Pratiksha, which one will be greater? V or E2 will be greater? Yes, tell me, V or E2 will be greater. Which one will be greater? If the current is passing in this fashion, V will be greater. So potential difference will always be equal to, okay, good Anjali. Okay, so V minus E2 divided by R2, right? This is the current passing through the resistor R2. Okay, that is equal to potential difference divided by the resistor. Understood till here, everyone? Good? Happy? In a closed loop, total sum of both current and voltages, it is not like that. In a loop, the total voltage drop or gain will be equal to 0, not the sum of voltages and current. We can't actually add up current and voltage. It is of meaningless. Okay, so let's simplify this. So what can you write? E1 divided by R1 plus, I'm taking this to left hand side, E2 by R2 will be equal to, taking V as common over here, so that is 1 by R2, and this V when it goes to the right, that will be equal to 1 by R1. Got till here, everyone? Okay, then what can you write? Cross multiplying E1 R2 plus E2 R1 divided by R1 R2 will be equal to V into R1 plus R2 divided by R1 R2. So cancelling this, what will you get? V will be equal to E1 R2 plus E2 R1 by, yes or no? Yes or no? Okay, someone was asking how V is greater than E2. It is because the current is traveling in this direction, and current always travel from higher potential to lower potential, right? Okay, someone was asking that, so I hope you got it. Okay, so understood how to do this? Everyone, all happy? Good, great. Okay, so one more question is there, the net value of the resistance. Okay, how will you find out the net value of the resistance? Now you understood that these two cells can be taken out. Okay, and it can be replaced by a single potential of V across a resistor R1 and R2, right? So how will you draw that particular figure? How will you draw that? You can, this is R1, this is R2. Okay, so both the cells are being replaced by a single potential V. Okay, and that V's value which we have derived now, what? E1 R2 plus E2 R1 by, yes or no? So how the resistors are connected now? How the resistors are connected? Who is going to tell me how the resistors are connected? It is connected in parallel fashion only. So equivalent value of the resistor will be equal to R1 R2 divided by R1 plus R2. All good? Happy? Understood? Okay, great. Okay, so Anshit, good. So many have understood. I think everyone have understood. Okay, Dhruv, parallel. Okay, you can type in Hindi also in the chat box. That's a great thing. You are unable to remember the formulas. If you are not able to remember the formulas, what you have to do is learn physics to the depth, learn theory. Once you are good with the theory, automatically all the formulas will come. Okay, happy? All good? So everyone is typing the value of the resistors in the chat box. Oh, great. So anyone sleepy in the class? Hands up. Anyone sleepy? Okay, good. Meenu, Mayuri, Roshan. Okay, Roshan, Daksh, Anjali. Okay, Shivanshu, I am right, thank you. No? Yes, it's a previous year question. Though I have forgot to mention the year in which it came. It's a previous. For JEE Advanced, NCERT is not at all enough. There is some extra theory also you have to do with the higher level questions. Okay, Ravindra, I took your name. So we are moving forward. So many questions are waiting for us, okay? So next question. Yeah, all are previous year questions only. Whatever we are discussing is only previous year question. I think it is from the past 3 years. Okay, so exam idea enough. I haven't understood that particular question though. Can you make it more clear? Okay, so the question goes like this for the next one. Great. Okay, Himadri, I took your name. Define relaxation time of the free electrons drifting in a conductor. What is relaxation time? What is relaxation time? Who is going to define me and who is going to explain? Who is it? Okay, I'll talk about the books at the end of the session. Okay, let's concentrate on the question. What is relaxation time? Relaxation time, you know that if it is a conductor, okay, think that this is a conductor. Okay, you are having a conductor, and when a current is being applied, look, when a current is being applied, the electrons will be traveling in this particular fashion, because it will always be traveling in the opposite direction of the current, right? Okay, so when it travels, you know that it will collide with so many electrons. Think that this is one electron and this is one electron. So during its travel, after it collides with this, it will be traveling, think that it is traveling toward the next one, and in between these two collisions, this electron will be taking a time. So that time taken for the electrons between a successive collision or between two successive collisions is simply called as relaxation time, and we'll be using tau. Yes, very good. Everyone is giving me the answer. Blitz, Dragon, Pratiksha, Daksh. Yes, good. So that is actually called as relaxation time. Okay, very good. Everyone is finding time to type also. We will be usually using with the simple tau, right? Okay, good. Now the question is, how is it related to the drift velocity? They are not asking us to derive. You just want to write the equation. So how is it related? Drift velocity Vd is equal to E by m into tau. I hope you know E is electronic charge. This capital E is electric field, mass of the electron, and tau is the relaxation time. Should I have to write it with a negative sign or a positive sign? Should I have to write it with a negative sign or a positive sign? Tell me that. Negative or positive? Negative or positive? Negative sign. Why it has to be negative? Because the drifting of the electron, this velocity is the velocity of the electron, is always opposite to the direction of electric field. In this figure, what is the direction of electric field? This is the direction of electric field, right? And the electrons will always travel in the opposite direction, right? Very good. So it is with the negative sign, right? Okay, next. Use this relation to deduce an expression for the electrical resistivity. So where this electrical resistivity is coming, I hope you know, R is equal to rho L by A. So this rho is resistivity, but we have to find out resistivity rho in terms of tau. How will we do that? We have already one equation. What? I is equal to N A Vd into E, also with a negative sign, because current is always opposite to the drift velocity of the electrons, right? Okay, so again N A, drift velocity, I'm going to write it as what? Negative of E by m into tau, and into E, this E is remaining. So negative cancel. So what happens? N A E square by m tau into E. How can you replace this E with? So E is equal to V divided by L. Okay, from the chapter electrostatics, I hope you remember electric field is equal to V by D, or the length of the conductor, right? Okay, all good? Great. So this E, I am going to write it as V divided by L. Yes? Okay. Now what I am going to do is V divided by I. So I am taking down to the right hand side. So V divided by I is equal to, look, V by I will be equal to m into L by N E square tau divided by A, right? Yes or no? Yes or no? So then V by I is what? What is V by I? What is V by I? V by I is resistance, right? Which can be written as rho L divided by A, right? Yes or no? Yes. So L is over here, L is over here, A is over here, A is over here. So the resistivity rho is actually being replaced by what? M divided by Ne square tau. Happy? Very good. All good. Right, hi Shrisha. Okay, Pratiksha got the answer. Exam idea, I don't know about that particular book. I haven't gone through, so I'm not going to suggest. Okay, so H.C. Verma is a good book, which I always used to refer when I was in my +2 series. It's a good book. Okay, Vishal, I took your name. So understood this particular question, everyone? Happy? We'll do one more question. You like 4 boards? Yeah. Yes. Arihant is a good book. Okay. Arihant, yes, you can use Arihant also. You can use. Good. So tell me. So should we stop now or can we do one more question? One more? Everyone will be with me without any sleep. One more question we'll do. Say yes or no? Yes? Good. Okay. Then it's great. One question. We'll talk about the books at the end. Okay. So don't worry. Now, what is given? The plot of variation of potential difference across a combination of 3 identical cells in series. Okay. Versus current is shown below. So, identical cells in series. So, how will it be? So, let me draw that first. Look. So, cell 1 with its internal resistance. Okay. Then cell 2 with its internal resistance R2 and cell 3 with its internal resistance R3. So this is how the connection is, right? All good. Now what does it say? The current versus voltage is given. What is the EMF? Okay, as it is same, I am going to write E1, E2 and E3 will be the same, right? Okay, and R1, R2 and R3 will be the same because it is already mentioned that it is identical cells. All good. Okay, now if you look from the graph, you can take the extreme points. Okay, so what is said in the extreme points? Look at this point. When the current is 0, the potential is 6. The potential drop across this 3 cells combination is 6. Okay, when the current is 0. When the current is 0 means this is an open circuit. In the open circuit only current will be 0. Which means no connection is there between the ends. Okay, current is 0, potential difference between these two, which means across this if you speak is 6. So V total is equal to how much? 6. How this V total is being there? That is equal to E1 plus E2 plus E3. As both are the same, I am going to take it as E plus E is equal to 6, which means 3 is equal to 6 and E is equal to, simple as that. You got the value for the volt EMF of the cell. How much it is? 2 volt. This is also 2, this is also 2, this is also 2. Got it? Okay, last part is, as I have told you, look, when the current is 0, voltage is 6 from the graph. When will the current be 0? When the circuit is open like this, right? When the circuit is open, the potential across this is what? E1 plus E2 plus E3. As they are identical, I am going to write it as E plus E plus E. That's all. I have written it as 6 or equated to 6. So then I just simplified. Got it, I hope, right? Okay, now let's see. Now let us take the other extreme part. Here, what is there? Voltage is 0 and the current is 1 ampere. When will the voltage be 0? Look, when I connect this, the current will start flowing, right? Yes or no? When the current starts flowing, whatever is the potential produced by this, it will be dropped across this. Whatever is the potential produced by this, dropped across this and dropped across this. Which means whatever is the potential produced by this cell, it will be dropped across this resistor only. So the potential difference between the ends will be 0 because there are no other resistors. Understood? I'm a Malayali. So understood this particular case. So here when the voltage is 0, current is maximum. So that particular case is defined in this, whatever I have drawn in the figure. Okay, here the voltage across this is 0 because whatever is the potential produced by the cell is dropped across this only. So no other potential is left. So this is what? 0. So there the current is equal to 1 ampere. How will you write this? Current is equal to V total divided by R total, right? Okay, so the current is given as how much? Current is given as 1 ampere from the graph. V total, how will you find out V total? Total potential will be equal to E1 plus E2 plus E3, which means E1 plus E2 plus E3, which is 3E, is equal to 6, right? I hope you have understood. E1 plus E2 plus E3, we already know it is 6. We have written over here, divided by total value of resistor. What is the total value of resistor? R1 plus R2 plus R3. As all are same, we can write it as 3R, right? So R is equal to 6 by 3, which is 2. Done? Happy? Great. So anybody is having any problems? No, I hope, right? So I have came with one more question, but it's fine. Best book for physics for what you're asking me, no? For the JEE or board exam. For the board exam, what I can tell you is go with the NCERT, okay? Cover the entire NCERT theory, do all the question which is on the side of the NCERT book, which means the exercises, then go with the previous year question. That is more than enough for your board exam. You don't have to take any other books or do all those stuffs. If you have still time, you can do some extra questions, that's all. For the JEE and all, I prefer HC Verma, okay, because it contains a question from the lower level till the higher level, which means till JEE Advanced you can use it. All good? Happy? My college, I passed out from NIT Calicut. Okay, I did my BTech from NIT Calicut in mechanical engineering. So I am a mechanical engineer, which says I can make a car for you. So guys, I hope you guys have understood. So if you guys have understood, why are you waiting for? Come and join the Vedantu 12th crash course. Okay, so you'll be getting the live classes. Okay, you'll be getting the study plans, analysis for the previous year questions, a lot much of things. What do you have to do? Instead of spending 12,000, if you can use this code AMECC, that code is for me. Okay, my code it is. So if you do, I'll also be benefited. Okay, so go to this link over here, apply this particular code. Once you apply this particular code, we both will be benefited, and you will get this particular course instead of 12,000, you will be getting it for 3,799. Okay, so get that and make your life awesome. Great. Okay, so guys, I hope you have understood the entire class. So if you have understood and if you think that the class was good and great, don't forget to like my video, fine. And if you think that this will also be good for your friends, share it, and please don't forget to subscribe, which will be a great inspiration for us also to make more and more videos for you. Ameer means rich. Okay, I'm rich by heart. Okay, so if you think that it's an awesome session, if it was an awesome class, don't forget to do all these things. Okay, so it'll be a great motivation for me also to do more and more questions for you, more and more classes. So now I should say bye, because another teacher have to come and take the class from the same studio. Okay, Abu, Triveni, Roshan, so bye. Thank you so much, Kaushik. All in one video, great. Thank you so much, Roshan, Mighty. So bye to everyone. Thanks for listening to my class. Okay, so you can give the feedback and the question in the comment box. See you all tomorrow at the same time for physics. So bye.